Hello everyone. What if the key to solving a murder was hidden in a single strand of hair? Or a drop of blood, so small you couldn't even see it? You'd think that's science fiction, right? But it's science, and it's very real. Today, I would like to discuss a topic which strikes me as being incredibly important, as it addresses a worldwide issue and demonstrates how advances in medical knowledge can impact global security, justice, and advancements of society. The topic I would like to discuss is DNA, particularly how DNA analysis impacts forensic science and criminal investigations. This is a topic I chose to research last year for my HPQ, and in formalizing my research question, I decided to focus on the United States because it is a global leader in this field. In fact, the United States was one of the first countries to implement DNA analysis in criminal cases, leading to the creation of the Combined DNA Index System, CODIS, in 1990. A national database that has revolutionized the future of millions of American citizens. Up to this day, DNA has been a fundamental tool to accelerate criminal investigations, reopen cold cases, and exonerate the wrongfully accused individuals, ultimately defending human rights and equality for all. To further understand this so pressing topic, let me take you all the way back to 1984, when the British geneticist Alec Jeffreys developed DNA fingerprinting, which completely altered the future of forensics by allowing unique identification of individuals based on their genetic profile. The first time DNA was used for conviction was in 1987 in Florida, during the case of Tommy Lee Andrews. Tommy Lee Andrews was a serial rapist who attacked several women in Orlando during the mid-1980s. All of his victims described a similar trend of events. A man broke into their homes, assaulted them, and then escaped the house. Police forces collected biological samples, so semen, from the crime scenes, and decided to send the evidence to a private lab for DNA analysis. When the DNA from the crime scene was compared to Andrews' blood, it was a match, and Andrews was convicted for rape and burglary and sentenced to 22 years of prison. After Andrews' conviction, DNA became a standard forensic tool, revolutionizing criminal investigations by providing scientific accuracy to link suspects with crimes. In many ways, DNA feels like the silver bullet, the tool that puts an end to all the inaccuracies of previous methods such as confessions, fingerprints, and eyewitnesses. However, it is essential to remember that like all tools, it does have limitations. It's a journey that turns invisible clues into undeniable answers. Automatic extraction of DNA reduces human error and accelerates the extraction process so that a technique known as PCR then amplifies the DNA to allow it to be analyzed and turned into a genetic profile. That profile is then uploaded into CODIS, where it can be instantly compared to DNA from other crime scenes or suspects nationwide, creating a flow of truths and hopes. However, despite DNA's infallible and powerful reputation, the use of DNA has also raised some serious ethical, societal, and legal questions, such as, should police be able to search public genealogy databases without permission? How do we protect the privacy of innocent people? Are certain communities overrepresented in DNA databases, creating systematic bias? There are also concerns about lab errors and contaminations, and something to never forget is that although DNA match might prove someone was present in a crime scene, it does not prove that they committed the crime. Consider the case of Josiah Sutton. In 1999, at just 16 years old, so 1 year more than me, he was convicted of rape in Houston, Texas, based almost entirely on DNA evidence. That evidence was processed by a crime laboratory, later found to have significant systematic bias, including poor quality control, insufficient trained analysts, and frequent contamination. In Sutton's case, a complex DNA mixture was misinterpreted and erroneously presented as a strong match. As a result, he spent 4 years incarcerated before being fully exonerated in 2003. His case stands as a sombering reminder that even DNA evidence is vulnerable to human error. Evidence can be misinterpreted, samples can degrade, and when mistakes are made, there are life-changing consequences. So I want you to remember this. DNA did change everything in American forensics. It gave victims voice and the innocent a second chance. In the US alone, 614 Americans were exonerated using DNA analysis, and 739,456 cases were assisted by CODIS. This proves that developments in DNA analysis can have huge social repercussions. The scientist is not an independent entity whose only concern is contributing to human knowledge. Instead, their actions matter. They really matter. Science and ethics are inextricably intertwined. The truth is ultimately within ourselves. So the next time you hear about a decades-old case finally being solved, remember, it might have just come down to a single, invisible drop of blood and the science that unlocked its story. Thank you.